Hello everyone. In this lesson I will show you how to use the name manager in order to name arrays of cells, or as I like to say, create pointers to an array of cells, or you might like to call them lists, data matrices, and etc. Also, in this video I will show you how to create the custom functions using the name manager. But before we begin the fun part, creating the custom formulas, let's see what sort of data do we have here and how can we name an array of cells. Now, first of all, let's see what sort of data do we have here, right? Here we have type of products. There are fruits, vegetables, berries, crops, and in the four following lists we have the members of this product. For instance, we have here fruits, and here's the objects that are fruits, and also we have kilogram per crate. Now, what is kilogram per crate? The comment seems to be hidden, so to speak. Okay, so kilogram per crate is the amount of product in kilograms that can be stored in a crate. Now let's see the information. All products are stored in crates of same size and volume, meaning that in the two crates that are of same size and volume, if we fill one crate with apples, we will be able to fit only 26 apples, and if we try to fill another one with grapefruit, we will be able to fill 40. Well, I know that it doesn't make sense in real life because, well, usually grapefruits are bigger than apples, right? But here we have a little note. Numbers are made up randomly, thus don't expect actual mathematical precision. So don't pay attention to the actual numbers, just know that we have these two types of data. Now our goal is to create a pointer to this array. To do so, it's exactly the same as creating a pointer to a cell. Well, first of all, you choose an array that you want to create a pointer to, and then you use the same methods that I showed you in the last video, which are, first of all, using the name box, accessing here and typing the name of the array that you wanted to have, or name of the pointer, as I like to call them. There we go. And voila. Whenever I choose this array, it will show me that the name of this array is type of product. Also, another way is to go to the formulas tab, click define name, and yada yada yada. It's the same as in the last video. Alright, now let's go and create custom functions, the interesting part, so to speak. Let's see what sort of data do we have here. Let's see the information here. The provided list shows the amount of different produce in crates stored in 5 different warehouses. All crates are similar and have same size and volume. Our task is to calculate the total weight of products stored in a warehouse. Alright, let's forget this for a second and let's see the actual list. Well, technically it's not a list, it's more of a matrix, but well, oh well. Let's see. What sort of produce do we have? We have fruits, vegetables, berries, and crops. Also, we have this data, average weight in kilograms per crate, which is the amount of kilogram of specified products that can be stored in a crate, which means that in one crate we can fit only 28 fruits. In the same crate, if we try to fill it with vegetables, we can fit 29. If we try to fill it with berries, 23, and if we try to fill it with crops, it's 37. Which means that in one crate can hold 37 kilograms of crops. Alright, let's see the columns. Here we have 5 instances of warehouses, which shows the first column shows number of crates stored inside this warehouse. For instance, in here we know that warehouse A stores 1,486 crates of fruits. And our goal is to calculate how much these crates weight in total. To calculate this, it's really easy, right? You take the number of crates here and multiply it by the average weight per crate, because we know that each crate weighs in average 28 kilograms since it's fruits. Now, First of all, let me write a simple formula. I mean, using the addresses without creating the custom function like this, and there we go. Okay, now let's create a custom function. In order to do so, we have to access, we have to do one of two. Either go to the define name and then erase something and add etc. and etc. But let's go do it properly, right? Let's access the name manager. As you can see, there are several pointers that I created in the last video, and also the ones that I created just now in the previous step here. So let's create a custom formula, custom function. We click new. Let's empty everything. And here we go. Now, one thing to remember, which is really important, because otherwise the formula won't work, always stand in the cell where the formula will be written. Considering that when you actually write the formula, it will take the cell references depending on its position. Now, if it's unclear to you what I just said, let me actually write the formula and then it will be much easier to explain. First of all, let's name what is a custom function. Let's name this custom function, right? Considering that it calculates the total weight, let's call it that, total weight. And considering that I want to show you how you can make a mistake while creating a custom function, let's call this total weight correct, which is that this formula, custom formula, will be correct. Also in comment, even though in this case the name of this custom function more or less describes what it does, well, actually it does not, it just shows what it what's the end result of this formula. But still, let's write an explanation, right? It calculates the total weight of produce stored in a warehouse. And we can make a further explanation, well, if it's not really necessary, but still. It calculates this by multiplying the number of stored crates by average weight per crate. There we go. This little comment describes what this function does, and to write the actual function. Now, usually, as you remember from the last video, in here we we choose a cell or an array of cells that you want this pointer to refer to, right? But the thing is that you can actually write the formula inside here. So we will write this equals, and here we will choose the cells that it has to multiply, right? We will click the number of crates stored inside the warehouse multiplied by the average weight. There we go. But here is the thing. Usually, when you are working inside this name manager, it automatically fixates the cells. In this case, we don't want it. We don't want full fixation, considering that whenever we will access this custom function, its result will be always the same if both of these cells are fixated, right? So here I will do the following. Considering that this is considering that this is the number of crates which is separate for each of the instances, we have to remove the fixation completely, because for every instance where this formula will be typed in, the number of crates will be different, like this. And then we go to the average weight per crate data. In this case, we don't need this fixation. We don't need the fixation by rows. And why is that? Because when we will call on this custom function, for instance in here, in berries, right here, it should take the average weight per crate for berries, not the fruits, which it would if I would have left the rows fixation too. So right now everything is correct. I will just click OK, close this, and now I will try to use this formula. So the name of our formula is total weight correct, right here. I click enter, and it shows that the total weight of 286 crates of vegetables is 8,294. Let's try check it like this, and we see that it's correct. Now let's try to copy this formula in all the cells, in all empty columns that we were supposed to fill, and voila, it works. It takes a number of crates and multiplies by the average weight per crate. Now let me show you why it is important to stand in to have the cell chosen in which this formula will be used. Well, for instance, when I created this custom function, I was standing in here, right? E12 cell, right here. But let's say I was standing right here, in which we would never use this formula, and try to create this custom function by standing in here, in G20. So let's do the same, right? Let's create a new function. Let's name it total weight, and yeah, in this case, considering that this is wrong, we will name it wrong. Well, comment isn't necessary, so we won't do this. And here we will write exactly the same formula that I did in the last one, right? It's this number of crates in which we remove the fixation completely. There we go. Multiplied by the average weight per crate. In here we remove only the rows fixation. And click OK. So there we go. Another custom function has been created. Let's access the formula here first. Total weight correct. Correct, I meant wrong. Right here. And as you can see, the amount is, well, correct, right? Now let's try to use it in an actual cell in which this custom function was supposed to be used. So in here, we will type total weight wrong. There we go. And suddenly it cannot calculate. Let's see why. And as you can see, instead of taking cell D12 and C12, which held the necessary data, it took the data from cells above. Now, why did it do that? When you create the custom function, well, when you create a pointer actually, it takes, let's say, it takes cells by referencing it from the cells that you are standing here. For instance, in this case, it knows that it is supposed to take data from cells that is located 8 cells above this one, G20, which is 12th row, and they are supposed to be, let's say, two columns left from the cells you are standing. So whenever you call on this custom function, which is wrong, it will always take the cells that are above from this function by 8 rows, and are left by 2 columns. Well, in this case, considering that this was a merged cell, it chose everything, let's say. But if I were to copy this in here, for instance, like this, oh, it's the same. Okay, let's see in here, and there we go. Again, it is 8 rows above G15, which is the 7th row, and it is 2 columns left from the G15. right here. So even though we just created a very simple function, custom function, which you could say that there is no need to create this function this easy, considering that it is more works and well, it's worse. But considering that later when you are creating the automatic workbooks, creating custom functions really saves you a lot of time, because when your formula is this long, it's really impossible, well, not impossible, but really hard to find a mistake. Let's say you made a mistake, calculation error in one part of this cell, right? Let's say that you have a formula that calculates some ratio of some financial data, and in this ratio each part of this formula is calculated separately, right? So there is just one big formula that consists of several parts, and you know that calculation is wrong, but you don't know which part made the wrong calculation, right? Well, when you name each part of this large formula and create the custom functions, you can easily access them later by going to the name manager, going inside here, and see what sort of data was inside. Make only one calculation, one modification inside here, inside the name manager, inside the custom formula form, so to speak, and then you don't have to worry about having another problem inside your workbook, right? You don't have to go access all the instances of your workbook calculations to check if you made the correction in every formula or not. By making correction here, you automatically change every instance of this every instance of this formula being used. So this was about it, and in next lessons I will show you how to use the data validation and its smart instances, well, using data validation along with lookup functions to create a smart version or double the data validation examples. Okay, goodbye.